So where limiting reactant comes from, this is, people get paid to do this in the real world. Like this is one of, I told you, stoichiometry is one of the more real life examples, real life concepts that we do. People get paid to do this in the real world. Here's how, right? Here's a basic example. If you're going to make a grilled cheese, most of us who make grilled cheeses that are normal have 2 pieces of bread to 1 piece of cheese. Would you agree with that? Yeah. Maybe as you get older, you got like 2 or 3 pieces of cheese in there. But for our purposes, we'll do 2 pieces of bread for 1 piece of cheese, right? And I give you 2 pieces of bread and 2 pieces of cheese. What's going to happen?
There's going to be leftover cheese.
There's going to be leftover cheese, right? Which ingredient is going to be used up first?
The bread.
The bread, right? Notice how I gave you equal amounts of bread to cheese, right? But the ratio of your product is 2 to 1, right? I need 2 pieces of bread for every 1 piece of cheese. Yes? Or that's actually your reactants to get 1 sandwich, right? So your bread will be used up first. Your cheese will be in excess. So all that time you saw excess on your last homework, that's what we were talking about. It's going to be leftover. There's going to be some left over, right? So that's what we're talking about today. Which one of your reactants is going to be used up and stop your equation, and which one's going to be left over? Okay? This is big business for some people, right? So if I look at this question, right, it's going to look very, very similar to what we've done. I've told you this before, right? It's the same math. You're not learning any new math today. What you're learning is a different way to use that math. All right? So the question is, sulfur is burned. We need to eventually get to letter D where it says, which element is your limiting reactant? So the question really is, when this reaction happens, which one of my reactants is going to be used up, therefore stopping the reaction? Because if you have 0 of a reactant, you're done. Okay? So what do you need to do first? Predict the products and write the balanced equation, right? We know we're going to be going from a reactant into a product, so that that's going to require a Stork step. So I need a balanced equation. So here we go. Sulfur is burned. Well, what do we know about when anything is burned? Is sulfur diatomic?
No.
It's not. So we're just good with S. Anytime anything is burned on Earth, what must be present?
Oxygen.
Now, little side note, burning is combustion. Combustion means the presence of oxygen. So if you want to write C or carbon dioxide and water here, why is that a problem?
There's no water. There's no hydrogen.
There's no hydrogen, there's no carbon in my reactant. So how in the world are we going to balance this if there's no hydrogen or carbon in my reactants? We're not, because that's the combustion of a hydrocarbon. This is not a hydrocarbon, this is a sulfur, right? So the product is SO2. How are you supposed to know that? You're not. That's why I'm telling you.
Okay.
Right? And look, and it tells you down here in the question what it produces. You all see that?
Yep.
Okay? So that's the first step. Now balance it. Good. You're done? Good. Because it's all ones. You don't believe me? Look at it. It's all ones, right? So the coefficient ratio is 1 to 1 to 1. Would you all believe me? Okay, let's move on. Right? So now it says how many grams of sulfur must be burned to produce 100 grams of your product? And the same question, just now we're using oxygen. How many grams of oxygen is required to produce that amount of sulfur? This is nothing new. This is last class, right? We're turning 100 grams of SO2 into sulfur. And then for D, we're turning 100 grams of SO2 into oxygen. Go ahead and work on that. And getting a lot of kids about how to get started. What we're currently in grams. What do I need to be in? I need to first get into moles. Why do I need to get into moles? Because my stoic step allows me to change compounds. The only way I can change compounds is to get the given into moles. If I'm given moles, that's a good thing because I can go straight to my stoic step. If I'm not given moles, I need to convert into moles. Then I can use my molar ratio to convert into a different compound. So in this case, grams of SO2 go there, grams of SO2 go there. Right? And that will get me into moles of SO2 in both instances. Cross out your units. Now, I'm missing that blank. That blank should be filled in with what? The molar mass of SO2. Now, whatever that molar mass of SO2 is, put it in there, right? 64.06. That's the molar mass of SO2. Now I can get out of moles of SO2 and into moles of what I want to be in. In this case, it's oxygen, and on top, moles of SO2, and in this case, it is sulfur. How do I fill in those blanks? Not the molar mass, the molar ratio, right? And it just so happens, guys, and I don't give you one like this on your test, because let's say I gave you one like this on your test, and you didn't do the molar ratio, it wouldn't change your answer, right? And so I'm not really testing if you know how to do stoichiometry. Does that make sense? So that's why I still need to see. These are ones. Where did those ones come from? My balanced equation. It's the molar ratio for my balanced equation, right? Now, am I done converting? How do I know that I'm not done converting?
You need to be in
grams. Grams. The question says grams for both of them. So I need to turn these mole counts into mass count. So 1 mole of sulfur and 1 mole of oxygen both equal the molar mass. And once again, that's 32. Anybody put 16 there? Good. Hopefully you don't, because we just talked about that. Yep. And sulfur is 32.06 maybe?
Yep.
I'm out of the moles, and I'm currently grams of O2. This is grams of sulfur. And now I should get a count, right? Now my true answer comes. So this one should be 50 point something grams of sulfur. This one's 49.00 grams of oxygen. Okay? Now, yes, you can obviously, if you're trying to get a calculator or sig fig answer on your test, then you would need to fill those in. Okay? But for the purposes of the new content today, that's good enough for now. All right? So what did we just do? We said, if we work backwards, guys, this is really like if you're dozing off, if you're still working, this is the part that you need to listen to. This is the new stuff for today, right? What we did was we said, I have the same amount of product. How much reactant of each does it take to get to that same amount of product, right? So if I look at my answers, which one has the least amount needed to get to the same amount of product?
Oxygen.
That's the least amount, right? Even by a little bit, not even a full gram. But what we're saying is we need the least amount of this to get to the same amount of mass. So what is my limiting reactant? Which one's going to be used up first? Oxygen. That is the reactant that limits the equation. So let me say this a couple different ways, because you're going to have some multiple choice type of test questions. Yeah.
Wouldn't you run out of sulfur first because it requires more?
This is going to be left over. So if you subtract the two, that's how much sulfur is going to be left over. That's going to be an excess. Okay? And we'll talk about that in a second. Okay. So what we're doing here, please listen to all of this and all the different ways that I could ask you. All right? Is which one of these reactants is going to limit all of the products? In this case, there's just one product. That's fine. But some cases, you might have 2 or 3 products. Which one of these reactants is going to limit how much all of these are made? Oxygen. So once all of the oxygen is used up, what happens to your reaction?
It stops.
It's cut off. It stops.
Is it just the one with the lower?
Yes. And that's the gist of it, but I might ask you in a complicated way because this is an honors class. Just to be honest with you, right? So we try to make things complicated by adding fancy words here and there. So I'm trying to say all of those words that you might read or see on a test. Okay? So which one cuts the reaction off? What happens to the reaction once the limiting reactant is all used up? It just stops, right? It's the least amount that is produced. Yes.
So, will we be going into, like, say you had 3 or more reactants?
No, you're only going to have 2 reactants.
Because, like, I was seeing where, like, if 2 react until 1 is gone, and then the other 2 react, we're not going to be.
No.
Okay.
No, because by chemical reaction rules, they all have to be present to get a product, to get those products.
Right, but, like, I guess.
Just stop there.
Okay.
We don't get that complicated.
Okay.
All right. This is already complicated enough. Okay. So this is what we're finding now on letter. Yeah. So what you might see is to calculate the excess. You're not going to have to calculate excess, but you might have to find out which one is in excess, right? So what we did here, we can calculate for it, but which of those reactants is going to be excessive? Sulfur. It's just the opposite one, right? That's not a difficult concept. It's just which one is not limiting, right? So the more test-like question is going to be down here at number 4. So y'all go down to number 4. All right. So how do you know whether to do just straight stoichiometry like you did on your quiz, and how do you know that you need to do like this double stoichiometry and find the limiting reactant? Well, look at this question. This is how it's going to be on your test, guys. I'm not going to say, hey, make sure you do limiting reactant here. I don't say that. You have to know what to do by the givens. So answer the question below, assuming we start with 28 liters of nitrogen and 25 liters of hydrogen gas. I don't even break it down into A, B, C, and D. I just say, what's your limiting reactant? Okay? So what should you be looking at? Number 1, I give you both. What are both of those? Types of what?
Measurements.
They're measurements, but where do they come from? They're both reactants, right? They're both reactants. Y'all see that? Once again, these are part of your notes, guys. This is an example that should be part of your notes where you're writing extra stuff beside it, okay? I give you both reactants. I cannot do a limiting reactant question without giving you all of the reactants. You see that's silly? I have to give you both reactants. If I give you both reactants, that should be a big red flag of, okay, I need to use both of these. These are both givens. These are both givens. What do we do to givens? That's our first thing that we write down, right? So what I should see is 28 liters of nitrogen and 25 liters of oxygen. Okay? So if you have 2 givens, if both of those givens are your reactants, those are 2 major red flags or whatever signs that you have a limiting reactant type of question. Yes. Yeah, I had done that every class for some reason. There we go. Is that better? Hydrogen, because we have hydrogen up there. So now the next question is, what is the maximum amount of product that can be formed? You ready? I give you 2 pieces of cheese. I give you 2 pieces of bread. Right? The question is, how many sandwiches can be made? Now, through logic, you can figure it out pretty quickly, but really it's like very quick math in your head. Right? We have to run the math through to the product to figure out how much of that is going to be made. So what I'm telling you to do in any limiting reactant problem, we need to take each of our givens and turn them into the product. So that's what you should be doing right now. Taking this given and give me how many moles of NH3, this given and how many moles of NH3, because they're both giving me an amount of product.
Like grams or cents?
This is volume, so we have a certain conversion from volume. Yes. All right. So I'll give you. All right, so this is where we're going to pick up, right? So most of you walking around, you at least got this. Why in the world are we doing converting from liters into moles for both of them? What's the reasoning behind that? So you can use your stoic step again, right? You cannot, the stoic step has to be moles to moles. So we have to get out of liters and into moles first, which is what I'm doing for both of those. Liters of each cancel out. Now I'm currently in moles of each one of them. Now I can get out of moles of each one, out of moles of each one, and into moles of what I'm trying to go into, NH3, my product. NH3, NH3. Now, again, please listen to me how I say this. What is the molar ratio of nitrogen to ammonia? 1 to 2.
Wait, so you say the one that's on the bottom first?
Yes.
Oh, okay.
And that's when I write it like that on a test, that's what I mean. The first one needs to go first, the second one needs to come, or the second one needs to come second. Top and bottom, right? What's the molar ratio of hydrogen to ammonia? 3 to 2. Okay? Now, why am I able to stop in moles? Here's why. In the question it says, what's the max amount of product? Does it say max amount of volume? Max amount of grams? Does it say max amount of moles? It does not specify. So I'm taking the easy way out. I'm taking the shortest route, and I'm stopping at moles. If the question happened to say, what's the max amount of mass or max amount of volume, then we would need to take this one more step. Does it make sense? Yeah. But it doesn't. So this, we're going to, like for the second time, and because it doesn't, I'm kind of, taking the easy way out. We're stopping here. Question. You good? No, it's not. Just ask.
Well, if you're just trying to get, and if it wasn't just the product of the whole thing, like, and you were just doing like the same thing,
Hmm.
when you just replace the NH3, just throw it in.
With what?
The NH3 on top, because you're trying to get the full product, right?
Mm-hmm.
But if you were just trying to find like the content of the nitrogen, would you just put it in there? Or-
Yeah, if I knew that one was an excess and one was limiting, like if and some of your questions over the weekend from last class said that like hydrogen was an excess. That means that we don't need to do this because I already know that this is an excess. Like we have enough of this. That's my limiting one. All right. So if I knew that, then I wouldn't have to do buffet. But I don't know that. That's kind of one of the new things for today, right? And so we're here, right? So what is my answer for each one of these? I believe this is 2.5 moles of NH3. And this one should be 0.7 moles of NH3. You find your mistake? I thought you had like 2 on the bottom. You're good. If this is what you got, then I read it wrong.
Wait, how did you get 0.7? Yeah, I got 6.7. I got 6.7.
No, I got 0.74.
So
I got 0.7.
this is the right setup. Make sure you don't have 3 on top and 2 on the bottom.
I don't.
Then it's a calculator issue.
Do you put parentheses and you do 25 times 2 close parentheses divided open parentheses 22.4?
If you're not using parentheses on the bottom and you're putting this all in one equation, that's your issue.
You're not supposed to do that?
So listen, but watch. 25 times 2 is 50. 22 times 3 is 66.
22.4.
But I'm saying, it's already over 50. So it should be a decimal number.
I got
Here, what?
Okay? So listen, here we go. It says, what's the max amount of product? Which one is my lower number? So which one is my limiting reactant? And anytime you see reagent, you can think of reactant. It's the same thing. So what this is saying is when I have 25 liters of hydrogen gets used up, my reaction is going to be cut off and I will have excess nitrogen. How much excess is what C is saying. We don't do that. We don't. There's a way to do it, and we could do it, but we're not going to throw that math on you as well. Okay?
Just put down.
So, right. And so your questions will be, what is my limiting reactant? How much product will that limiting reactant make? We answered both of those right here. My limiting reactant is hydrogen. It will make 0.74 moles of my product. And your excess reactant is N2.
I think my calculator's broken. 'Cause I did
We'll look at
the
it.
same.
We'll look at it. Okay? So guys, listen. This is how the business world works, right? If you want to be like, not that you want to be, but this is what some of the job of what a chemical engineer does, right? I'm the boss. I own a factory. I own a business. I have all the money, right? I have someone that goes out and buys stuff for my company. Well, they go to places like Costco and Sam's that only sells things in certain quantities, right? You go to Costco, you want peanut butter, you only need that much, but you have to buy 2 huge jars of it. You can't get around it, right? So I'm going to bring in that much of that and that much of that because that's the cheapest quantities I can buy at a time. You all following that? Right? Your job as my chemical engineer is to tell me how much ammonia will get me from that amount. Because next class is really where the business part comes in about, how much money somebody's going to make off of this product, about how much they will make or how much they should make. Okay?
So number C, you changed to which one?
Letter C is just which one is in excess, yeah.
Oh, because you put how much of it is.
I know.
It says.
That's why I said we're not doing that. It's just which one is in excess. You should be able to identify, not calculate. Okay? Now, that's one of the more basic examples. Go up to number 3.
Do you know the answer if we did the letter C?
No, I haven't done it yet. I haven't done the math for it. So if you look at number 3, how does 3 change a little bit from number 4?
There's 2.
The biggest change is I have 2 products. Number 4 had how many products?
One.
So you knew right away which one to run your answer into, right? What's your biggest question here? Which one are we going to use? And I'll tell you, it doesn't matter.
I'm going with iron.
Pick either one. It doesn't matter.
Why? That's weird.
Because the question is why? No, everything in here matters, right? Everything, I don't get my choice in here. Well, you do this time, okay? Because this is the next concept that you need to know. Please listen to this. And if you're writing out notes, this is something that you might want to write out, especially next to this example. Once you find your limiting reactant will limit all of your products, not just the one that you pick. So some of you might pick carbon phosphate. Some of you might pick iron carbonate. And I'm telling you right now, it doesn't matter. You will both find the same, if you do it right, you will both find the same limiting reactant. Okay? So what I'm telling you to do right now is find the limiting reactant of this equation.
You said like the first part limiting factor.
Right? It doesn't, so whatever is your limiting reactant will limit all of your products. Whichever one is in excess will be in excess for all of your products. Okay? So go ahead. And guys, this one takes a little bit longer because you have to find molar mass of these big compounds. And so it takes more time. You can stop at moles here too. So there was a question, and hopefully none of you are doing this, but some of you might be doing this. Can I take both of these givens and turn them into the same product? And my answer was, you have to. You don't get the choice from there. Why do we have to run it into the same product? What are we doing with these numbers at the end? Look at number 3 or number 4. What do we do with those 2 mole counts? We did what? We compared them, right? How am I going to compare a gram count or a mole count of carbon phosphate to a mole count of a completely different compound? Is that apples to apples? No. We need to compare apples to apples. So whichever one you pick is the one you have to do both of them for. Everybody clear with that? That might be another note that you write somewhere. Just so you don't do too much work, or you're doing the right work. Whichever one you pick is the one you run both of them into. Okay, so here's your setup that you should have. I got some empty spots in there that you should know how to fill in, right? How do you fill in my first step? What goes in those blanks? Molar mass of each one of those should go on top and bottom. The molar mass of calcium carbonate, the molar mass of iron phosphate. Okay, that's another concept, right? Then what goes, here's my stoich step. How do I know that this is my stoich step? Because we're going from one compound into a completely separate compound. Where do I find that molar ratio? Your balanced equation, the coefficients of those compounds. So iron, let's start at the top, calcium carbonate, 3 to 1. The bottom, iron phosphate to calcium phosphate, 2 to 1. Now, how do I know if I can stop here or not? Look at the question. These questions don't really specify, so we're just going to stop at the mole. If they did, you would have to take them to whatever the question asks you to go to. Yes? So when I get this answer, my top answer is what?
0.308.
What about iron phosphate?
0.14.
0.15 grams of NH3. Why am I only labeling my bottom one? Because that's my answer. Well, that's part of my answer. We're not done.
NH.
Oh, I'm sorry. I was thinking the last one. Grams. And this one was, I turned this into calcium. Moles of Ca3. There we go. Is that better? It doesn't matter. Because we don't need it. Like, that's... what I'm saying. Okay. So, why are we not done? Number one, we still have to answer B. Which one's my limiting reactant? Iron phosphate. Iron 3 phosphate, thank you. And so which one is in excess? Calcium carbonate, right? But we're still not done. Those of you that are very detailed readers, why are we not done? I am technically giving you an amount. Now, on these questions, they wanted us to do grams to turn it into a mass, but we're not going to because of time, and this technically suffices the question. But why are we not done? Read, please.
They want how much can you make?
15.15 moles. What's the key word up here? Anybody?
Of each product.
Why is each the important keyword up here?
Because that's telling you have to go figure out what the product
Both
is.
products, which means I have two answers up here that should be circled. You want to see that? So, once again, the business, let's say business again, right? I bring all this stuff in. I want to make and sell calcium phosphate and iron carbonate, right? You work for me, I pay your salary. You say, okay, you can make 0.15 moles of calcium phosphate with these ingredients. And that's all you report to me. Why am I firing you? I want to sell both, right? That's what each product means. So now I need a mole count for my next one, my other product. So the question is, do I need to do, I need to start from scratch, right? No. I already know what's in limiting and what's in excess, right? Your excess really means that has plenty of it. That's not going to limit how much each one of my products I can make. What will limit how much I can make of all my products is the iron phosphate, which means I should do what?
Figure out how much is there.
I start with 45 grams of iron phosphate. I've done it once by turning it into calcium phosphate. Now what do I need to do?
You need to turn it into the product.
Now I need to turn my iron phosphate into my other product, iron carbonate.
It's the same answer. It's point.
It will be, but I still need to see the work. Listen, so you need to turn it, like you need to do the dimensional analysis. How much of my other product can be made from 45 grams of iron phosphate? Why do I only need to use iron phosphate now? Because that's my limiting reactant. That will be cut off before my calcium carbonate is used up. So do you have to start from scratch? No. But do you still have to do some dimensional analysis to find your other product? Yes. So I should see everybody doing their dimensional analysis. And this is moles of, and that's moles of the same thing. Now, in this case, those of you that are actually doing the math, you'll figure out that it comes out to be the same mole count.
Shouldn't it be 0.1?
No. 0. What's the same thing?
It's without the 5. Because your dimensional analysis.
Well, it should technically be 1. Well, it should be 2 because 45 grams has 2 sig figs in it.
So if we did iron carbonate, it would be the other.
Right. So let's say some of you chose to do iron carbonate first in your limiting reactant part, right? So you already found that one. Now you'd have to go back and do the calcium phosphate. That's why it truly doesn't matter which one you start with. Okay? Now, how does it give us the same answer for each one? Well, look at the molar ratio. 2 to 1. If we were to turn both of these into a mass, that's where we would see the difference because the molar mass of iron carbonate is different than the molar mass of calcium phosphate. That's where we would see a change. But just in the mole ratio, the moles, they're the same. Okay? Now, just like in all math, some of you